All right. I suggested to finish the part 2 and 3 questions last night. Again, the rules here, don't ask me because you want to see if you got the problem right or wrong. Don't ask me because you didn't do it. Okay, don't waste your classmates' time with that. Do it because you found the answer you thought was correct, checked it, still not really too sure what you did wrong. All right, that's the type of questions I want. I don't want a question, did I get this right or wrong? You know where to go to find that. And I don't want questions because I didn't do it. All right, I'm not checking it. So, all right, that's on you. And again, I'm going to keep saying this every day at the beginning of class. The grade you get on this will be reflected in the time you put into it. If you've been a 90 student all year long, you know who doesn't care? The Regents exam doesn't care. Okay, it does not care that you've been a 90 student all year long. Okay, what it cares about is the preparation you put in from yesterday to 2 weeks from tomorrow. Okay, because we are 2 weeks from tomorrow away from this exam. Anthony, you had a question? Or Billy, go ahead. Number 35. I didn't ask you to do it, did I? That's a part 4. Yeah, we're going to do that one in either today or tomorrow as a class. Okay. Yeah, I just asked you to do parts 2 through 3, but we will get to that. Don't worry, we will get to that one. So hopefully your questions will be answered. Yep, Bella. Number which one? 28. Okay, 28's a circle question. All right, and this is Bella asked the question, so this is not a knock against her one bit. All right, this is going out to every single one of you in here. All right, which I can tell already. You're going to have to pick your favorite number 1 through 30 and place your phone in there soon because I'm about to just explode. Okay. All right, try it again, and we're all putting it there. This is not a knock against Bella at all. I'm telling you guys a strategy to study. All right. Anytime you're doing any of these review problems for me, all right, or you're just reviewing on your own, have this right next to you, what I gave you yesterday. Okay, have this right next to you. Okay, like this problem, for instance, and I'm still going to do it. I have no problem doing it. All right, but in your packet here, you will find a page that's got all the circle rules. Okay, and my feeling is if you look it up and take the time to do it on your own, you're going to remember it. Okay, so just always have this next to you anytime you're going to do one of these problems. All right, circle question. There's 2 things that are drawn for me here. I have a secant, RP, and another secant, RT. And I'm looking for the lengths. Anytime I have lengths of tangents or secants, I'm going to remember whole times external equals whole times external. I think on the work that the guy put on there, he just calls it WE equals WE, short for whole times external. All right, if I label this really quickly, RS is 6, ST is 4, all of RP is 15. How long is RQ? All right, so you give me a whole secant, which I'll take the 15, times its external part, which we called X, and then whole secant of 10. Everyone all right where I'm getting the 10 from? Times its external part, 6. So 15x equals 60. X equals 4. Please, please take a deep breath and actually is that what I needed? Is that what I needed, or am I going to have to add something to it? Find RQ, go to your diagram. RQ we called X. Perfect, I'm done. I don't need to add it, subtract it from anything. I'm done. So 4. Anything else here from the suggested assignments we want to go over? What's up, Nika?
I don't need to go over anything.
Sure.
I just have a question.
Absolutely. Go.
So immediate, all it does in the triangle is it's the perpendicular bisecting.
No.
No.
It's not perpendicular.
It's not.
It just bisects. It is drawn from a vertex. It is drawn from a vertex to the midpoint of the opposite side. That is it. Could it be perpendicular? If the triangle's isosceles or equilateral, yeah, it would be. But it does not have to be. The only condition a median has to satisfy is it's drawn from a vertice of the triangle to the midpoint of the opposite side. That's it. That is it. All right, that is it. And the three of them intersect what's called the centroid. All right, which maybe we'll get to in the next 8 days. We'll see. Nope. Unless it's isosceles or equilateral. Okay. Scalene triangle, no. Will not bisect the angle. Only isosceles and equilateral. Good questions here. Anything else from the parts 2 through 3 we want to cover? Anything else? Yes, Bella, go. I'm probably not going to answer this for you the way you want, but really there's a lot of different ways. You know, why are they congruent? You could pull out a side, a side angle side. Just similar. You could say the sides are in the same ratio. You could say angle, angle. Side similarity. You could say side angle side similarity. It's a whole bunch of. You don't even have to bring any of these up and just say, hey, they're congruent and similar because all three pairs of sides are congruent. That's fine.
Just say that they're congruent, and because they're congruent, they're also similar.
I like that. Yes, congruent triangles are also similar. That's fine. And I'm glad these guys asked this question because I forgot to mention this yesterday. Please do not take the Regents exam thinking he'll know exactly what I'm talking about in your mind. I don't know if you guys know this, but I am not allowed to correct your Regents exam. Okay, I'm not allowed to correct it. So please don't get in the mindset, oh, Mr. Carlino will know exactly what I'm talking about. I did this all year. I won't. Okay, because I'm not allowed to correct it. So another teacher will be. Okay, now. Okay, any abbreviation I've done this year, fair game. You start making your own abbreviation hieroglyphics, you're skating on thin ice. Okay, but anything I did, like we just did one last period. Like you can write parallelogram like this, that's fine. Definition, CPCTC, all good to go. Okay, anything we've used this year, good to go. Yep. Anything else? Okay, do you have any topics before you want me to review until I get to some questions from that exam? Catherine, what's your topic? CSSTP. Yep. Okay. CSSTP is used after proving two triangles congruent. Okay. So let's say I have, and I'm just making this up off the fly here, ABC, DEF, and let's just say I wanted to prove, oh boy, AB over ED equals AC over DF. Let's say it was part of a proof, because that's really the only time I would come up with CSSTP would be in a proof. So let's say my proof statement is the following. So before I can do that, I need to prove the triangle similar. And good time right now, let's go over 3 different ways to prove triangle similar. Okay. 3 ways. I got angle, angle. Prove 2 pairs of angles congruent. Another way. That's basic. If we're doing a proof, that's the way we're doing it, angle, angle. But it may not be a proof. Might be a multiple choice question. Or why are these 2 triangles similar? Maybe it's not angle, angle, but it could be, what's the other 2? Side, angle, side similarity, which means the sides are in the same ratio. And then the final one, side, side, side similarity. All 3 pairs of sides are in the same ratio. Not 2 out of 3, all 3 pair. So going back to your question, Catherine, I would prove the triangle similar probably by angle, angle. And then I would say the proportions are equal by CSSTP. Okay? And I'll keep going here. We're going to keep going because you could make this one step further. After you prove the sides are in the same ratio, you may have to do this. AB times DF equals ED times AC. What would the reason for that be now? After you've just proved the ratios are equal. Product of the means equals product of the extremes. Great question. Great question to go over there. Mason, let's go. You got it. I'll show you because I want you to use it if you're comfortable using it. No problem cannot be done using sine, cosine, tangent from SOHCAHTOA. Okay? Maybe law of sines is going to be easier for you to use. That's up to you, but I'll show it. And I'll show it using one of the problems you guys had last night with the whole campsite deal. I'll show that real quick. Okay, here we go. Using law of sines now. Let me just review using law of sines. So on this problem yesterday, when we went over it, we found TS first. Everyone agree we found TS? Okay, I'm going to flip the game on you. I'm going to find TF first. Okay, I'm going to find TF first. So this is perfect review here. 72, what do we call the 400 side? That was adjacent. And now if I'm going to find TF, everyone, what am I going to use? Hypotenuse. So now I'll use what with A and H? Cosine. So I'll say the cosine of 72 equals 400 over x. Adjacent over hypotenuse. Okay, again, make sure your calculator is always in degree mode. That'd be kind of bad if you were, wouldn't be. Let's see, I'm going to do 400 divided by cosine 72. All right, here's what I get. I get 1,294, not going to round because I'm not done with the problem. Okay, you good so far? Everyone all right? Mason, you good here? Everyone all right? What I did there. Okay, now I'm going to deal with this triangle instead of the big one because I can use law of sines on any triangle I want. Does not have to be right. Okay? So here is your answer to your question. How would I use law of sines here to find this side here? Well, I'm going to say x over, or actually I just found that, so I'll just put I'll put an arrow here. What's the angle across from it? In that triangle now. Don't give me an angle in a different one. What's the angle across from this side? So I'm going to say sine of 55 equals y, the side the problem asked me to find, over, can you find the angle right here? 108. So sine of 108. Make sure if you're going to use this on the Regents, all four values come from the same triangle. Don't pick them from different triangles. All four values come from the same triangle. And then you're on your way. Good? Okay. Advantage to using law of sines, it can be used on any triangle you want. Okay, versus SOHCAHTOA can only be used on a right triangle. Answer your question there, Mason. Billy?
When would you know to use Hills and Sas?
The wording of the problem. I'll pick one. I may have one that we're going to do today that we can just do right now. Yep, let's go. 23. We just might as well do it right now. It was on the agenda for today. When to use Hills and Sas. My eyes light up when I see these words together in any problem. Altitude drawn to the hypotenuse. Right there, Hills, Sas, Hills, Sas, Hills, Sas. Altitude drawn to the hypotenuse. That's an automatic Hills, Sas guarantee there. All right, so there's your answer to your question, Billy, is when I see altitude to the hypotenuse. All right, so let's actually do this one and figure out which one I need to use. All right, so I have a right triangle. The hypotenuse is EF, so E and F can go anywhere here, which would make the other vertice, what's missing? C? Okay. Line segment CD is the altitude to the hypotenuse. So I know I'm going to use Hills, Sas, Hills or Sas. It's just a matter of which one. EC is 10. EF, ooh, 24. What is ED? All right, nice, perfect. Think you know what we're going to use? Don't say anything. Just say it in your mind if you think you know what we're going to use. I'll make it easy on you. Is the altitude involved? Okay, so what do we have to use if the altitude's not involved? Hills, yep. H, L equals L over S. Let's slowly go over this now. What's the H in hills stand for? Hypotenuse. There's only one hypotenuse you use, and that's the hypotenuse of the large right triangle, which is how long? 24. What's the L in hills? And that's one of the legs from the large right triangle. Do I know one of the legs from the large right triangle? 10. And what do we know about the legs in hills? Always the same. So 10. And then what's that S stand for? Segment. Now take a look. There's two of them here. And I know you're just going to put an X in there because that's the only one labeled. But what's the rule? Which segment do you always use? Next to the leg you just put in. The segment next to the leg you just put in. So in this case, X. Pretty easy problem, right? Once you know the hills and SAS part of it. So you have 24x equal to 100, and then you're going from there. So 4.2. So good timing there, Billy. Good timing. Everyone else all right? Usually one of them pops up every year. Altitude to the hypotenuse. Hill SAS. Hill SAS. Be prepared. I'm just going from past knowledge. Be prepared on a hill SAS, maybe to factor. All right, maybe have to do some simple factoring. All right, that's where I've seen factoring come up as on a hill SAS problem or a quadratic formula. Bella, you had a question. Go. No, no, you are never going to be forced to use law of sines. Anything should be able to be answered by using sine, cosine, or tangent from SOHCAHTOA. You are not going to, that's like an extra to the geometry curriculum, and I just show it because it makes problems easier than doing sine, cosine, tangent. Remy? Emma, you're on deck.
You know that like explanation thing that we had to do in one of the units? It was like a long thing, and then in the quiz we had to like fill in the explanation.
I think it was like the graph. The coordinate curve or something.
What was a proof where you just had to fill in the reasons?
No, it was like explanation.
Oh, I know. You're with the rigid motions.
Yeah. Do we have to do that?
Yeah, that'll.
Can we like go over what that is?
Yeah. Like number 25.
Yeah.
Yeah.
I just wrote a translation doesn't change the size.
That's fine. You don't. You can say it's a rigid motion, doesn't change size, but just saying changes size or shape.
So do you have to say that it's a rigid motion?
Not unless you say it doesn't change size or shape. Like if you don't say that, you got to say it's a rigid motion. Okay. All right, but that's what you're talking about right there. Yeah. Yep. So you got to say, oh, it's a translation, it's a reflection, it's a rotation. Those do not change size or shape, so therefore the triangles are congruent. Okay. Yeah, you're going to see one of those every year. They put one on. Yep. Emma, and then Nam, and then I'm going back there. Here we go.
So back to the translate question, I was wondering, you could go over how to use the inverse tangent. So if you're given the two sides.
Okay, so how do you? Okay, so finding an angle. Is that what you're asking me?
Yes.
Campsite. Okay, let me clear this out. So you want to find an angle here. That's a tough one. Because you can just find the angles. In this one, I'll change the problem, but in this case, you can just 180 minus these two. You find that angle, 180 minus those two. So you could do, okay, now let's just say I wanted to find it a different way. I had no idea what those were. All right, totally changing the problem. Okay, that's 400. I'll make this side 650. And you want to find, I'm just say that angle. Okay? You go through the same process. I go from this angle now and I say the 400 is opposite, right? The 650 is adjacent. So I still pick the one out of the three that I need to use. So with O and A, tangent. So I'll say tangent of X equals opposite 400 over adjacent 650. But I won't cross multiply when I find an angle. Now I'm going to go to my calculator and do the inverse of tangent and plug in 400 over 650. And there you go. Okay? Do not cross multiply. Anytime you need to find an angle using sine, cosine, or tangent, you use the inverse. Nam! How would I do factoring? Where'd that beast go? There it is. Okay, this probably isn't going to work out, but I'll change it up. Let's say instead of 24, let's say it was 24 minus x for some reason. Okay, good. So this would be 24 minus x here now, right? When you cross multiply Nam, you would get x times 24 minus x, right, equals 100. Good so far? You'd get 24x minus x squared equals 100. And once I see an x squared, that's when the factoring bell goes off. And I need it to be positive. So I'm going to move all this to the right and get x squared minus 24x. And this isn't going to come out because I just made it up, but plus 100. And then in this case, if I did ask you to factor, you're looking for two numbers that do what? Multiply to 100, add to negative 24. You find those two numbers, right? Get the values of x, probably one you're going to eliminate because it makes a negative side. Okay? And again, if you don't want to factor, what else is available on the formula sheet that you can use? If you don't want to factor it, what else is on the formula sheet that you can use? Quadratic formula. You can use quadratic formula if you need to. So that's what I would think Hills and Sass become in factoring. Good now? Back in the corner now. Don't worry about it. Don't worry about law cosines. Too much info, won't need it. Anything law signs. And that's based on your how comfortable you are using it. Okay, don't worry about law cosines. All right, too much to remember. All right, too much. Just use law signs if you're comfortable with it. Okay, Dylan. Bella. Okay, too many people back there. Next. And this is great. I haven't gotten this in years, this many questions on day one. Yes, Madeline? Doesn't matter. Doesn't matter. Okay, let me put it this way. This is the 4th year of this Regents being given. They changed the version of it 4 years ago. Have I seen an indirect proof ever? No. But does that mean you shouldn't be prepared for one? No. Here's a quick story why I say that. Because 3 years ago, never did we see halves of equal quantities on a proof. Never seen it. 16 years of teaching, never saw halves of equal quantities. What happened that June? They had to use halves of equal quantities as one of the steps. So I'm not going to say don't say never. Okay, be prepared for everything. Do an indirect proof. Okay, I'm going to have to, so if you guys want to copy it down, fine, because it's not in anything I've given you. So I'll find one I gave from that unit, and then we can do it. What unit was that in? I'm going to say unit 5, indirect proofs. There it is. We'll do the, Yeah, we can do this one. Okay, so if you want, that's fine. If not, you just want to watch on, that's fine too. Doesn't bother me. Because I think I said this, probably I didn't. There's 4 parts to the exam. Part 4 is going to be a proof. Part 4 is one 6-point question, and it's going to be a proof. What type? No idea. So if it's indirect, you can thank Madeline after the exam. Okay, I have no idea what the proof's going to be until you see it. But I can guarantee there will be a proof. Part 4, last question. Question 35. What would be awesome for us if it was a coordinate geometry proof where you just use distance, midpoint, slope, but can't just put all our money into that basket. Because last year it was a beast with that rectangle one we still have to do. Just let me know when everyone's ready. We'll attack this beast. How do I know this is indirect or got to be done indirectly? Anybody remember how I know it's got to be done indirectly? Emma? The proof statement says prove something's not equal. That's automatically has to be done indirectly. Good. Yep. All right. So anybody remember our first step to an indirect proof after the givens? Mason? Okay. Well, it's an assumption we're going to make. That's our reason. Yep. What is the assumption we're going to make? Because it's a specific one. Proof statement. Do not do the opposite of the givens. It's the opposite of the proof statement we're going to assume is true. So we're going to assume angle A is congruent to angle C, and I can actually use that as a given. Mark it in your diagram. And what are we going to try to do? Now you go to your givens. What are we going to try to do? Prove the opposite of one of them. Probably which one out of the two I want to prove the opposite of? The not equal one. So I need your help proving me that BD and BE are congruent. All right. So now this just becomes a proof now. We've talked about the indirect part. Now prove to me somehow that BD, side BD, and side BE are congruent. Got a step for me, Nika?
Yeah.
Just a step, because I don't want to reveal it.
Yeah, we could just say that angle B is reflexive.
Okay, angle B is reflexive. Now let me stop there because some of you are going like, where are you going with this? Anybody know what we're doing here? To get these two sides congruent, we're eventually proving a pair of triangles congruent. That's what we're doing. Specifically, here's your pair that we're proving congruent. We're proving these right here, that one with this one. Okay, because take a look. Everyone see how DB is a full side in the blue one, and BE is a full side in the yellow one. So we could say CPCTC at the end if we need to. All right. I think we're done, aren't we? Because the other given was AB is congruent to BC. So I think we have everything we need to prove them congruent. It's just what method you're going to use. So triangle BAE is congruent to triangle, if I go BAE, BCD. Well, this one's tough when they overlap. What's the method going to be? It's either going to be angle, angle side or angle, side, angle. Guys, just look at one triangle only. Don't look at both of them. Ready? Make this real easy. Draw it out if you have to. So here's B, here's A, here's E. I have this marked, I have this marked, and I have this marked. Makes it pretty easy now. What method? Angle, side, angle. And then why do we need the triangles to be congruent? So we could say BD is not equal to BE. Oh, sorry. Whoa, whoa, whoa. Oh, man, one job. One job. I got to tell you what first. That they are equal. Come on, you're better than this. BD is equal to BE. Let it roll off the tongue. Wait a second. It's congruent, but the given said they weren't congruent. We have a contradiction, don't we? So that must have meant your assumption, the proof statement. Angle A is really not congruent to angle C. And I kind of gave away the reason already, but assumption led to contradiction. Go ahead. For me, you did because this was an above average class. Now, for the Regents, not required. Okay? All right, we go a little bit higher than here than what's regularly expected on the Regents. If you want to throw it in, go ahead, but I don't need to know where the contradictions are. Yep. In this case, if we were to write it, show me where your what two steps did you contradict yourself? I contradicted myself in the given there with BD not equal to BE and showing that it is. So it would be 1 and 5 here. It's never the assumption in the final one. I never put that. It's one of the givens and then where you contradicted it. Okay? Yes? Okay. Okay, I'm going to have to go deep again in there. Whew, we are just getting after it. This one's only going to be 3 steps, so not too long. Say that That's pretty important because a couple years ago, kids got busted to do that. All right, that we had to take a point. What now I'm saying is, you know how the givens are usually written up here? You pull one of these, you put a line there, it's not going to fly. All right, you will get a point taken off for that. I'm telling you right now. All right, they've started doing that, taking a point off for you guys not writing in the full givens. Or doing one of these instead of writing the actual word given, to writing a big G. That's always classy. Okay. All right, here we go. Halves of equal quantities. How do I know halves of equal quantities? Probably should come up in a proof. You are going to be bisecting. What do you know about these two angles that are getting bisected? Okay, you're going to be bisecting congruent angles. Maybe the word bisect isn't there. What other vocabulary term might be there that's saying you're going to take halves of these two equals? Maybe not bisects, but maybe what other vocabulary word says we're taking half of something? Midpoint. Midpoint. Okay, so if we're bisecting two equals or taking the midpoint of two equals, probably going to be halves of equal quantities. I said it was a 3-step. Why is it not 2 steps when you just write halves of equal quantities? Well, what are you going to take half of? That's what I need to know here. What are you going to take half of? Well, you're taking half of the congruent angles, right? So my first step here is going to be half of DCB, one of the angles, and you let me know what it's equal to. Half of DCB. And you could put 2 different choices, this angle and this angle, but I only care about one of them. And what angle do I care about? Because I could say it's equal to angle DCA, or I could say it's equal to angle S. Which one do I care about in this proof? Angle S. Yep, so I'm going to say that's equal to angle S. Come on. There we go. And then I'm going to take half of the other angle, DAB, and say that's equal to angle, oh boy, half of DAB, R. Not by halves of equal quantities, though. Definition of a bisector. Then you could say R is congruent to S. Sorry. Halves of equal quantities are equal. So bottom line, when to use halves of equal quantities are equal? If you're cutting in half a pair of equal quantities. So 2 angles, 2 sides are equal, and you're going to cut them in half. And you want to show the halves are equal. All right, we're going to keep moving here. Somebody else, we had other hands raised here. Emily. Partitions. There's the partition question in your exam. I know that. I just don't know if I cut it out yet. I know it's in the multiple choice section. There's definitely one in that June one. Anybody see it before in that June exam? Anybody see it? $14, okay, go ahead. Okay, 14. Very little that I can guarantee as far as problems go on this exam. I can guarantee there's going to be a proof at the end. Probably a density question and probably a partition question. Those are probably the 3 I can guarantee you'll see. And a construction, of course. Construction. All right, so we're dividing this into a ratio of 2 to 3. How many equal parts? 5 equal parts. So we start with the x-coordinate. The x-coordinates go from -4 to 1. What's that a distance of? If you're on the x-axis and you go to -4 to 1, that's a distance of 5. That's perfect because I have to divide this up into 5 equal parts, right? So every time I divide it up, I'm going 1 unit. But look at the ratio, 2 to 3. So what am I going to multiply? I'm not going to just go by 1 unit. I'm going to multiply it by 2, the first number there. So 1 times 2, you're going to go 2 units from your starting position. What x coordinate did I start on? -4. So we can go from -4, add 2 to the right, and where do we end up with? -2. I know that there's only one multiple choice that has that, but let's do the y's because it might be a part 2 or 3 question. On the y's, we're going from -2 to 8 now. What distance is that? That's a distance of 10 units. All right, a little different here because now I'm going 10 divided by 5, so we're going to go 2 units every time. But are you just going 2? What do you have to multiply the 2 by? Still the first number. Still the first number. Hey, just so you know, the 3 would be used if I went backwards from E to D. But I'm going D to E, so I keep using the 2. So I'm going to go 4 units. Where did we start this process? At what y coordinate? -2 plus 4. I end up at -2, 2. You have 2. You can't leave until 2 hours in the exam. I highly recommend on a partition question, graphing these, connecting them, and making sure that bad boy is on the line. Because if it's not on the line, you don't have the right partition point. Great, great job today. Keep them coming tomorrow. That was getting after it right there.